Hello viewers, you're welcome today to our class. Today we are going to be looking at projectile. Projectile is a very common topic in physics that you see in most of the external exams, WIAC, JAMB and the likes. So what is projectile? What is projectile? Before we look detail into it, let us just see what it means. What is projectile? A projectile is simply an object thrown into the air and allowed to move under the influence of gravity. It is the object thrown into the air and allowed to move under the influence of gravity. Projection, it could be throwing this object horizontally, could be throwing it vertically. However, it could be throwing it at an angle. Projectile motion is the motion of a body in air acting under the influence of gravity. Okay, so the motion of a body in air acting under the influence of gravity only. Okay, so if that is the case, we know in exams projectile questions come in three forms. One, a body projected vertically upwards. When a body is thrown vertically upwards, something happens as it is going up and as it is coming down. A body projected from the ground at an angle. A body projected at an angle. When a body is thrown at an angle, it will have a trajectory. When a body is projected vertically upward, let's start from there, it goes up and comes back through the same path. Okay? When a body is projected at an angle, it goes this way and have this trajectory. Okay? And then when a body is projected in the number 3-way projection type should come is that when a body is projected horizontally, it comes this way. Okay? When a body is projected horizontally, it goes from a height, it goes this way. So these are the three possible ways projectile will appear in a question. Either a vertical projection at an angle to the horizontal, and then horizontal projection from a height. So let's look at the terminologies or the paths of the trajectory of a projectile. So if we have something like this to represent a projectile, okay, this is the point of projection. This point is the point of projection. And u is velocity of projection. Which of course is the initial velocity, the velocity at which the object was projected. While this is the angle of projection, that is the angle of the made by the projectile with the horizontal is the angle of projection. H here is the maximum height of the projectile, while the distance from the point of projection to the point where the body returns to the same level of projection is what we refer to as range. Okay, so as a body is moving at every point of this trajectory, we have the vertical component of projection, we have the horizontal component of projection. We have the vertical this place now it is coming down, so we have the vertical components of projection and the horizontal components of projection. We have the vertical components of projection and the horizontal components of projection, which in calculation we are going to represent the vertical components of projection with v subscript y, while the horizontal components of projection with v subscript x. Okay, so as a body is moving in a trajectory of projection, there are two velocities, the vertical and the horizontal. Because if it is moving at an angle, there is always the vertical component, there is always the horizontal component. Okay? Okay, so let us take note of that. Other things we need to know of the projectile are, okay, let me just draw the diagram smaller here so that I will use it to explain what I want to explain. This is the range, this is the height, maximum height, This is the initial velocity. So we have what we call time of flight. Time of flight. Because we need these terminologies to be able to solve questions. What is time of flight? Represented with capital T and mathematically as 2u sine theta all over g. Of course, you know that this is the time of flight. The u is the initial velocity, the velocity of projection. The theta is the angle of projection, and g is acceleration due to gravity. Okay, what is time of flight? Time of flight is simply the time it will take a projectile to move from the point of projection and return to the same level of projection. That is the time it will take this projectile to move this way and come this way. Or you could say it is the time taken by a projectile to cover the range. That is what we call time of flight. The time it will take the projectile to move to its maximum height and to return to the same level of projection is what we call the time of flight. Okay, we also have another one we refer to as the maximum height. Maximum height. And I told you the maximum height is the vertical distance from the point of projection to the maximum upward point of that projectile. And the maximum height is represented with h, which is equal to u squared sine square theta over 2g. Another is time taken to reach the maximum height. Time taken to reach the maximum height is represented with small letter t. If the time of flight is 2u sine theta over g, that is the time it took the projectile to get to this height and return back, then the time it will take it to get to this height, that is time taken to reach maximum height, the time it will take the projectile to move from here to this maximum height is going to be half, because it's dividing this trajectory into two. It's going to be half of time of flight. So the time it took a projectile to get to its maximum height is equal to this divided by 2. And if you divide this by 2, you are going to have u sine theta all over g. So this is the time to reach the maximum height. And then the fourth one is the range, is what we refer to as the range. The range, I told you, is the horizontal distance from the point of projection to the point where the body gets to the same level of projection. And then mathematically, the range is represented with u squared sine 2 theta all over g. I will not bore you with the derivation of how this formulas. It is the application that we are going to do. And also, there are other ways we are going to solve this, because there are situations where the body is not going to be projected at an angle theta. It is going to be projected horizontally from a height. In such situation, these formulas might not actually work this way. That is where we are going to combine these formulas with what we have in the equation of gravitational motion, so that with the application we will be able to resolve and solve whatever nature of question that we see. We are going to see that in our next video, where we'll solve series of questions from WAEC and JAM to really explain better projectile. See you in the next class.